Okay, Patterns and Chaos. I watched the video that you linked and I responded to it, but the audio was all messed up, so I had to delete that. The the thing is this. I mean, I don't want you to think. I don't want you to get offended when I challenge your ideas. I mean, if I was dismissing the ideas, then I would just dismiss them. And I'll admit you could get offended because though I'm not dismissing them, I'm bringing up issues that I have with them, which could be the grounds of such a dismissal. I mean, basically, the value of a scientific idea does not rest in the reputation of the scientists that espouse it. It doesn't matter what their reputation is. The idea has to stand or fall on its own. For example, there's characterizations that I've been responding to about Niels Bohr. It really doesn't matter what his statements on the philosophy of science are. That's what he meant when he said his theory was really just a mathematical model. To defeat it, you have to come up with a model that does better at predicting experimental results. So you can't, you can say that cosmologists are believing in a science fiction, but if you make a specific statement like that we know that space is curved, well, I'm familiar only with the definition the cosmologists are using. And by their latest measurements of WMAP, which you say the science that it's based on is science fiction, but still it is a coherent model. And based on the model of and the definition of what it would be to have a flat or a curved time space, uh, there's measurements this device can make that discriminate between the two, and it's found a flat universe. So if you go straight, you will not come up from behind like you do on the surface of the Earth. Um, but I'm interested and willing to talk to you about your theories because I think on a philosophical level, sometimes we wait quite a long time for our philosophical ideas to make an entry into the physical sciences. For example, relativity. I mean, there was an idea of a perspective-based relativity from ancient times and skeptics, but for that idea of relativity to make it into a natural philosophy, it's physical science, we had to wait quite a long time, centuries. So it could be that you have some philosophical principle in your theories that will need to be taken into account. If you really want to differ on a scientific level, then you have to um, accept the scientific method of it, which is to prove your point with a predictive model that is able to better match experimental results. Now, I don't know about light curving because of space, because I think that it's flat. It does curve because of gravitational fields, but the thing is, those do tend to cancel out because the light can pass. If the stars are at random, then a random ray traced by some light will, it'll go on one side of some stars and it'll be on the other side of some other stars, and they will tend to cancel out. And when we look at gravitational lensing, we're looking at light that is bent by two different paths and managed to converge back on Earth. But just by you know millions of a degree or hundreds of thousands of a degree or something like that. I mean, they're millions of light years away, and on our sphere are not even our celestial sphere are not apart more than fractions of a degree. So I I don't think you should assert that space is that we know that space is curved unless you give your definition of curvature very specifically. And there is no reason really for I don't know that the light from Earth does not curve back around to Earth as far as I know. Some of it does. Some number of photons will somehow bounce back to Earth. Some of the light off of Earth shines up on the moon, bounces back to Earth, and we can see that light. But some general principle of curvature, I don't see how you can justify that. And also, we don't actually know that light curves because of the curvature of space. I mean, you can interpret it that way. Einstein liked to interpret it that way. But the fact is also just that light falls when it's in a gravitational well, just like objects do. You know, if you shoot a gun and turn on a flashlight at the same time, the photons and the bullet are both falling at the same, you know, in the same force of gravitation, the same speed as if you just dropped an apple. You know, they would all hit the earth at the same time. It's just that they're flying forward. So in the case of light, it goes forward so fast it would be in outer space before it hit the surface. In the case of a bullet, it will hit out there somewhere unless you have a strong enough gun, in which case you could actually put the bullet into orbit. So I mean, space can be curved is one way to look at it, but the other way to look at it is that light also, you know, falls in a gravitational field, and that's what causes the curvature in its path. But but anyway, so yeah, I want to give a challenge to this because, you know, if you're taking your ideas seriously, then, well, so am I. It doesn't mean I agree with them. It means I have a critical analysis of them, which is not, you know, critical in the negative sense. It can be constructively critical or whatever. It's just analysis. So so yeah, if you're going to deny that space is flat, fine. It's definitely flat by the definition cosmologists have been using, okay, because they define these things really well and well enough so that this experiment, this space telescope, could determine which was which, and it's flat. So you must have your own definition